Hi students, welcome back. Let's continue with the Tomasulo's algorithm. In the previous video, I explained what exactly the Tomasulo's algorithm is. Now, in this video, I am taking an example, the steps of execution using the Tomasulo's algorithm. Okay, so try to watch this video till the end, then you'll get a clarity on what exactly this algorithm is and how this algorithm is executing the machine instructions. So I had taken the basic example, whatever it is there in your textbooks and whatever the material. First try to understand this concept, then you can easily implement on whatever the machine instructions they are given in the examination. Okay, so try to understand. So what are the table formats I am writing here, and what is the flow of executing the each and every machine instruction in the processor, everything try to understand it clearly. Then whatever the statements is given, okay, you can easily write the steps of execution. Now let's have a look on this problem. A steps of execution using Tomasulo's algorithm we have to be explained. So assume we have, this is important, the question, try to understand the question. 3 loaders are there, 3 adders are there, and 2 multipliers are there. Okay, means your circuit consisting of 3 loaders and the 3 adders and the 2 multipliers are there. The following machine instructions are executed in a pipeline order. So these are the instructions are given. These are executed in a pipeline processor. Okay, so load instruction, load, okay, multiply, subtract, division, addition. So these are the machine instructions which are executed in a pipeline processor. And these are all the destination registers, F6, F2, F0, F8, F10, F6. So these are the destination registers and these are the source registers. Okay, so and one more point they are given is, whatever the load instruction is there, load instruction is trying to execute. I'm talking about the execution, it takes 2 cycles. And for addition, okay, for addition, it takes 2 cycles. Either addition or the subtraction, whatever it may be. So this it will take 2 cycles. And coming to the multiplication instruction, the multiplication instruction is going to take 10 cycles. And whereas the division instruction is going to take 40 cycles. So what are the points you have to be remember? 3 loaders are there, 3 adder circuits are there, 2 multiplier circuits are there. Okay, and each load instruction takes 2 cycles, addition take 2 cycles, multiplication take 10 cycles, and division taking 40 cycles. Okay, so these points you had to be remember that. So now let's try to see what are the steps that are involved for execution of this machine instruction. So here I am writing, what is load is how many cycles? Load takes 2 cycles. Okay, and add takes 2 cycles for execution. Mul take 10 cycles. And division is taking 40 cycles for execution. Okay, so in the problem what they are given, 3 loaders are there. So here I have taken load 1, load 2, load 3. 3 loaders are there. Okay, and 3 adders. 3 adders, add 1, add 2, add 3, and 2 multipliers, multiply 1 and multiply 2. So this is a question they are given. So first try to write the instructions in an instruction status. In instruction status, try to write all the instructions whatever they are given in the exact format. So in the question whatever, because it is a pipeline processor, right? So whatever the format they are given, try to write all the instructions in that format. So in the instruction status, we are trying to issue the instructions, registers, and execute and the write result. In the reservation stations, a time, how much time this adder is taking to execute the instructions, and how much time this multipliers, means the cycles. And here the busy, whether the adder, because 3 adder circuits are there, 3 adder circuits are there, okay, and 2 multiplier circuits are there. So these 3 adders and 2 multipliers, whether these adders are busy or not, here you are writing. And OP means what operation this adder 1 is doing, either doing addition or it is doing subtraction. Subtraction or addition, whatever it is doing, if that operation is doing, that adder will be busy. So addition or subtraction. And VJ, VK are the, it holds the values of the registers. Okay, and QJ, QK are the reservation stations which waiting for the source registers. The source registers are writing here and the source register values are writing here. Remember students, QJ, QK. That is here this is I and this registers are J and these are the K. Okay, JK are the source registers. If whatever the source that is waiting, that have to write here. Okay, and if these are free, then those values will be shifted to VJ and VK. Okay, and this is the function register result status. Register result status. Result status means this is the result. F6, F2, F0, F8, F10, F6. So this will hold the values, right? The result value is holding these register. So loading 32 into R2 and we are moving that value into F6 and loading 45 into R3 and moving to F2. And F2, F4 are multiplied and these value will be moving to F0. F6 minus F2 and the value will be shifting to F8. And F0 divided by F6, the result will be moving to F10. And F8 plus F2, the result will be moving to F6. That means these are the register result status. F0, F2, F4, F6, F8, F10 and up to F30 I had taken. Functional unit. Okay. Now let's start the procedure. So first is load. So load, what it is doing? So first it is in the first clock cycle it issues the operands. Okay. So whenever it is issued, the load one is busy. Yes. What is the address? 34 plus R2. 34 plus R2 is the address. So what clock cycle it is? Clock cycle 1. Okay, I am erasing each and every clock cycle. So this is the status of the clock cycle 1. Now go to the clock cycle 2. Okay, clock cycle 2. In the clock cycle 2, what's happening? What happening? In the clock cycle 2, this load is starting issue. Okay, and this load is started execution but not completed execution in one clock cycle because load is take 2 clock cycles. So wait, don't try to complete it because it starts at the 2 clock cycle but it is not completed. It is waiting because it has to execute the load will take 2 clock cycles, whatever I had said. Okay, so and the same time load 2 is busy. Yes, with what address? 45 plus R3. Try to write here. So here what the result F6. So F6 contains what? Load 1 because it is not still completed. If it is write back the results, then the value will be writing for F6. But F6 now holds only the load 1. Load 1. And what is F2 is holding? F2 is holding only load 2. Because still it is not completed its execution and it will not return the value. So it has to wait. So write it here in the functional status, register result status load 2 and the load 1. Now coming to the clock cycle 3. So let's take the clock cycle 3. So what happening in the clock cycle 3? In the clock cycle 3, multiplication operation is started. Okay, multiplication operation is started. And first load instruction is execute its instruction because it takes 2 cycles, 2 and 3. So it takes 2 cycles. Execution is completed. And this load is started its execution in 3rd cycle. So what happening in the 3rd cycle? Multiplication is issuing the commands. Okay. And load 1 is completes its execution and load 2 it starts its execution. Okay. Load 2 it starts its execution. Still it not write the result. Whenever it writes the result, make the load 1 as free. So multiplication starts its execution. So what I have to write in the reservation station? Okay, in the reservation station, multiplier is busy. Addition, add 1, add 2, add 3 are not busy because still we are on load operations. So load does not require any adder or multiplier to perform the operation. Whenever performing an operation, adders and the multiplier circuits are required. But load is generally loading the data from the memory and from the memory. Okay, taking the data from the memory. So no need to adder and the multiplier circuits are required for the load. So multiplier 1 is busy. So with what operation? Multiply operation. Multiplication operation is busy. What the Vj and Vk values for F2 and F4? Is F2 is free? No. F2 is busy with what? It is busy with the load. It is not yet completed. The value you didn't get it. Okay. The value here you didn't get it. So write it in reservation station because this is the Q. F2 is the J value. Qj. Okay. Because this is I and J, K. So in the Qj, write it as load 2. Don't write the values because it is not completed. So make it as a reservation station because F2 is still busy. And F4 is what? Right here. F4 is a free only. So write here register F4. I am writing under the K because this is these are two operands, source operands. Vj is busy still because F2 is still not yet completed. So that's why I have written it as a load 2. Okay. So now what the result? Result will be stored on F0. So F0 is holding what? Multiplier 1. So this is the third clock cycle. I think up to here it is clear, right? So now go with the fourth clock cycle. What's happening in the fourth clock cycle? In the fourth clock cycle, this load is trying to complete its execution. Okay, it's complete 3 to 4 execution. And this is write back the result. Whenever it write back the results, try to make the free. Load 1 is free now. Load 1 is free now. Okay. And subtraction is started at the fourth cycle also. So 3 operations here I done in the fourth cycle. Subtraction started at the fourth cycle. Okay. And this load 1 is free. Whenever it is free, erase this. Okay. Remove this. Load 1 makes it is not busy now. Okay. And make the load 1 here as the value with value. Let's take memory of A1. Memory of A1. Okay. So memory of A1. And load 2 is started its execution and it's trying to complete its execution. But it is not write the result here. It is not write the result here. So subtraction is started. Subtraction means what? Adder. So adder 1 is busy now. With what operation? Subtraction operation. And what are the values? Source register F6 and F2. F6 and F2. So what is the F6? F6 anyhow it is completed. The load is completed. So what is the F6 value? M of A1. Write it is M of A1. What is F2 value? No. F2 still not completed because here load 2 is there. Okay. So try to write in the reservation station. Load 2. I am writing under the K because J is already is there. But the K value it's not free. So write it in the reservation station as load 2. Okay. So now the subtraction is over. So this is fourth clock cycle. Now go to the fifth clock cycle. So what happening in the fifth clock cycle? In the fifth clock cycle, so first this load is completed its execution. So whenever it completes its execution, try to erase it. And try this load 2 is not busy. So that means F2 is holding the value. So what value F2 is holding? So now here you have to write F2 is holding the value. Okay, what value it is holding? Let's take, remove the load 2 and write memory of A2. Memory of A2. So wherever the load 2 value is there, so this is the load 2. Now shift this load to memory of A2. Okay, and shift this load 2 value to multiplier, memory of A2. Okay, because load is over. So all M of A2 is shifting to VK. QK is a reservation station. So it occupies the source register. And here QJ is the reservation station. So whenever you got the load value, F2 value, move to the VJ. So multiplier is F2 into F4. Okay, but it's not complete. Even though you got the values, it's not completed its execution because multiplier will complete its execution in 10 cycles. So execution takes 10 cycles. So still it is not yet completed. Still it is not yet completed. So in the 5th clock cycle, a division is also started. So we are still in 5th cycle. In the 5th cycle, we are just load is completed. Division is also started. Okay. So whenever the division is started, multiplier 2 is yes. Okay. What operation? Division operation. So what is F0 and F6? F0 and F6. Okay. So F0 value, it is busy with the multiplier. It's a destination value, right? F0 is a destination value. So Qj here, this is F0 is multiplier 1, busy with the multiplier 1. The reservation station of Qj is busy with the multiplier 1 because it is not completed. When it completed, whenever 10 cycles are completed for multiplication, then only it release the F0 value. So until that, this is a multiplier 1 will be holding here. And F6. F6. So what is the F6 value? M of A1. F6 is already completed by the load. Okay, by the load 1, F6 is already completed. So M of A1 is stored in, because this is I and J. So J is M of A1 and Vj is F0. F0 is not yet completed. So store it in the reservation station. So this is 5th clock cycle. Now start with the 6th clock cycle. So in the 6th clock cycle, what happening? 6th clock cycle, adder is started. Adder is started. So, and multiplication starts its execution. At the 6th clock cycle, adder started. So, this addition is started. And multiplication starts its execution. At the same time, subtraction is also started its execution because this multiplier and subtraction both are the two different circuits, multipliers and the adders. So both are started its execution. Both are started its execution at the 6th cycle. Not yet completed. Okay, it takes 10 cycles to complete. It takes, subtraction will take 2 cycles. That is what saying. Add or subtract is on 2 cycles only. Okay, so at the 6th clock cycle, add is started. So this is yes. So what is Vj and Vk? F8 and F2. F8 and F2. So F8 is still, it is not yet completed. F8 is in adder 1. This is F8, right? It is not completes its execution. It doesn't write the value. Whenever it writes the value, then only you can use this F8. But it is not completes its execution. It doesn't return the value. So, this F8 is holding adder 1. Vj. Under the Vj, you have to write what you have to write? Adder 1. Okay, it is in reservation station. So you are not supposed to write here because it writes only the values. So whenever it is waiting, you have to write adder 1 is waiting. Then what is F2? F2 is anyhow completed. What is the value of F2? M of A2. M of A2. Okay, so this is the 6th clock cycle. Then what happening in the 7th clock cycle? 7th clock cycle. So in the 7th clock cycle, subtraction is completed its execution because subtraction will take only 2 clock cycles according to the question. So 2 cycles it is completed. So even though it is completed, so all the remaining process will be the same. Okay, and here let me write F8 is what? F8 is still waiting with the, So M of A1 and F8 is adder 1 is holding. Okay, and F10, what is F10? F10 is holding multiplier. It is waiting for the multiplier. These are the resultant result. So register result status. So these two are the values, but F0 is waiting for multiplication and F8 is waiting for adder 1 and F10 multiplier 1. Okay, so this is what happening. Now coming to the 8th clock cycle. in the 8th clock cycle, what happening? So in the 8th clock cycle, subtraction is started its, okay, the subtraction is going to start it, completes its execution. Okay, subtraction is completes its execution. So whenever it completes its execution, it gets the F8 value. What is F8 value? F6 minus F2. Remove this adder. F8 means F6 minus F2. F6. What is F6? M of A1. What is F2? Minus M of A2. Okay. M of A1 minus M of A2. Or else you can write M1 minus M2. It make it is easy for you to remember that. Okay. F8 is M1 minus M2. F8 is. Okay. Whenever you got this result, okay, subtraction F8, that is, this is the adder 1. Okay. So this, let me complete it. So at the 8th clock cycle, multiplier MA2, okay, and this F6 now it becomes the, this is updated with adder 2, because the adder 2, F6 is still busy with that, M1 minus M2, and multiplier, this is F10 is multiplier 2, sorry, a little bit confusion, multiplier 2, don't get, F10 is division, right? The division is holding multiplier 2. It is waiting for the multiplier 2. So this is what happening here. Now let's go with the 9th clock cycle. So in the 9th clock cycle, this will be started its execution. Started its execution but not yet completed, because it takes, the adder will takes 2 clock cycles. So everything will be the same. Everything will be the same. So this adder 1 is completed, right? Adder 1, 4, 8, this everything it's a completed. So let's write the result here instead of add 1. This is M1 minus M2. Sorry, this is opcode. I have to write. Subtraction is add, and this is VJ here, right? Okay. M of A2, okay, and this is M1 minus M2. What is the adder 2? Subtraction. F6, F2. F2 is holding what? M of A2. And what is F6? F6 is holding is M1 minus M2. Now it is updated with adder 2, right? So it is holding M1 minus M2. Now here this adder will now holding F6. F6 is holding adder 2. F8 plus F2. It has to perform F8 plus F2. But when it has to perform, whenever it completes its execution, then only it performs F8 plus F2. So in the 10th clock cycle, it's completed its execution, but it's not write the result. It completes its execution, but not write the result. So this is everything, it will be the same. So multiplier M of A2, RFF4, M of A1, and it is waiting for the multiplier 1. Now at the 11th clock cycle, this adder is also completed its execution and write the result back. Whenever it write the result back, F6 now holds, instead of adder 2, now F6 holds F8 minus F2. F8 minus F2. F8 means what? I am writing here. M1 minus M2 plus MA2. So M1 is nothing but M of A1 minus M of A2 plus MA2. This is the addition. So F6 is holding the value. Okay. So now adder 1s are completed its work, and the multipliers are still has to wait, because till 10 clock cycles are completed, multiplier it is in the execution state only. Okay. In the 12th clock cycle also it is same, 13th same, 14th same, and the 14th also same. Now coming to the 15th clock cycle. So 6 plus 10, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 10 clock cycles. Whenever the 10 clock cycles are there, the multiply completes its execution. That's it. Completes its execution, not it doesn't write the values. Now, at 16th clock cycle, it completes its execution. Whenever it completes its execution, at the 16th clock cycle, whenever it completes its execution, okay, so this becomes multiplier m of A2. So, whenever it completes its execution, F2 into F4. F2 into F4. So, F0 contains what? F0 contains what? F2 into F4. What is F2? M of A2. What is F4? F4 is nothing but a register value 4. This is R. Let's take the register R. So, multiplier 1 is what? Multiplier 1 is nothing but M of A2 into R4. M2 into F2 into R4. So, F0 holds F2 into R4. F2 is M of A2. And F4. F4 is nothing but a register value. Register value, it's already there. So, R. So, register value M of A2 into R is updated. So, at 16th clock cycle, division is started its execution. At 16th clock cycle, division is started its execution. So, at 17th clock cycle, division it started its execution. 16th, it is right result. And at the 17th clock cycle, division is started its execution and takes 56. Till 56, it takes to complete its execution, because division is 40 cycles. From 70 to 56, it takes almost 40 cycles to complete its execution. Okay. So, at 57th clock cycle, division write backs the result. Division write backs the result. So, in the F10 position, division is going to write back the result like F8 is what? M1 minus M2, okay, divided by F2, M of A2. So, in the place of F10, it is going to write this. And all these values or reservation stations are getting free. Okay, these are all getting free. So, whenever the data is over, the operation is over, it's try to complete it. And whenever the operation is over, the data is going to be erased in the reservation station. The register result status contains the exact values. So, F6 is holding M1 minus M2 plus M of A2, and F2 is holding M of A2, and F0 is holding M of A2 into R, and F8 is holding M1 minus M2, and division is holding F10 is M1 minus M2 divided by M A2, and F6 is this value. So, total how many clock cycles are taking, at what time cycles the values are writing? Load 1 at 4 clock cycles, 4th clock cycle, and load 2 at 5th clock cycles, and multiplier at 16th clock cycle. So, like that, based on these clock cycles, how much time it is taking to execute these instructions, or explained it clearly. So, I hope you understand. Please try to implement take some other instructions and try to work out with this format. Don't get confused. Only take how many cycles. The main thing here is how many cycles are taking for each instruction. So that you have to remember that. Thank you.